Okay, thank you and welcome to this week's Lunch and Learn by yours truly, Dan Hotka. I'll be your host today, as always. My same short disclaimer. And I am an Oracle ACE director. Part of the ACE program is to share our knowledge amongst the Oracle community. I like doing these lunch and learns. I like the shortness of the webinars, the technical content, and gives me the ability to speak to more of you more often. I'm also available at most major user groups, trade shows, and conferences. I am well published. I've got almost 14 books in the works. I'm working on number 14 as we speak. I'm regularly published in journals, and I regularly blog. You can register for these Lunch and Learn announcements. You'll get the links. You'll get any other useful information that I deem. Like this time, there is a call virus going around where they actually call you and say they're from Microsoft support, and then they tell you that you've been hacked, and then they can help you, and then when you let them help, they take over your computer and goof it all up for you and ungoof it for a fee. I'm not even sure they ungoof anything, but a lot of people have been getting the call. I got some feedback already on this, that someone, their timing was impeccable in that they had a call into Microsoft. They thought it was the call back and went down the wrong path. But any rate, when you get that when you get a call from them, do ignore them. Any rate, I do training for a living. I do have a one-course fee. I price my training more like a consulting gig, so it's very affordable for groups of people. Unlike the other training outfits that price per person, I price per course. On-site, over the web, and I do have a computer portable lab when we're on site. I can do all of these courses, a mix of them. Let me know what you need and see how I can help. Here's my Volkswagen hobby. This is a 71 bug. This was one that I did. I think it's been on the road 10 years now, and I use it behind my motorhome, and it's been a fun project. This is a 1960 bug. No horsepower, no gas gauge. 6-volt system. I put around Des Moines with the thing. You can see the license plates on them both. They were both buckets. They were both quite the rundown vehicles when I got them. The blue one was out of a salvage yard in Los Angeles, so it was just not rusty at all. This red one was actually an Iowa find. Usually cars of this era have long all rusted out. This one was really not very rusty, although it was really in rundown shape. And I still enjoy them both. And if for those of you who participated last week, you saw the Izetta hobby that I have going. So I still collect my antique vehicles, and I enjoy them. This week, we're going to continue the Explain Plan series, talking about how the hard parse works. The links to today's presentation and the slides, these slides, and the links to the presentation will be up on my website shortly. Okay, so today's topic is what is involved with a hard parse. Okay, and this material comes right out of my SQL tuning course again, and don't mind sharing it with you. And so, like I say, this is the content that you would get if I were on site. So how does it work? Okay, cost-based optimizer tries a variety of combinations of the tables and the where clauses. When you have a multiple table query, it'll try it only joins 2 tables at a time, and then it will join in the additional one and an additional one. It tries those combinations. The where clauses, same thing. It does not know which step is going to do better row elimination based on the table order other than trying it. The trying of the combinations is called permutations. How many permutations or how many tries are you going to get? How many tables do you have in your from clause multiplied by about how many where clause predicates you have in your where clauses, and that's roughly the number of permutations you're going to get. Where clause predicates are the where clause items that are related to a table. Okay? We're going to talk about regular queries mostly. They use the lowest cost method. The cost number that's in your queries on the top line, that is the number that it is comparing with the other permutations. If two of them come up with the same number, the same cost number, it takes the one that it came up with first. This might account for why you run stats, you get slightly different explain plans, because the other one, maybe it ran first and it won the race. Partition queries, we're going to probably cover them in another Lunch and Learn. Basically, they do what's called pruning. They access the partitioned objects, and they like to prune down to just the partitions that they need. So partition queries work a little bit differently. They do the pruning first, and then, of course, Oracle's looking for the fastest access method based on elapsed time, not the lowest cost method. Cost, by the way, is related to physical I/O, but it is not exactly physical I/O. There's a lot of things that multiply into this. You know, the disk drive speed, processor speed. As Oracle progresses, they multiply more things in there. But when Oracle comes up with the lowest cost, it feels it's got the query that's going to run the quickest because it's going to do the fewest physical I/O. Okay? So it's related to physical I/O, but it's really not just physical I/O. Okay? Cost-based optimizer does the multiple iterations looking for the lowest cost. Okay? Permutations, and I'm going to talk today about query transformation. It does query transformation once, and then it drops into the permutation process. I call this a brute force approach to coming up with the lowest number because Oracle uses the statistics at hard parse time, okay, the stats that you've run. What Oracle is after is using the statistics, educated math, and really not dumb luck so much as guesses, educated guesses, on what are the row counts associated with each line of that explain plan. How much row elimination is a where clause going to do? What are those? How does that affect the overall cost of the query? Oracle really doesn't know, so it tries the various table combinations, the join methods. If you got 3, 4, 5 tables, it'll join two different ones, coming up with different combinations. For each permutation, it will try each of the join types because, again, it does not know whether a nested loop or a hash join is actually going to work out the best. Okay, so it tries each of these permutations, returning cost numbers. And is the overall cost less than the prior permutation? If it does, that becomes the one to beat. Okay, so it does a bunch of these permutations, loop-de-loop, looking for the lowest overall cost. Query transformation, it does this once before it starts the permutation process. It was introduced in Oracle 9. Actually, they probably came up with the term in Oracle 9. They've been doing some transformations for a long time. Transformations include, but not limited to, changing the data type so that they match. If you've got you're comparing a number to a character in a where clause item, it usually puts a to-num on the character side. It does this internally. It does this at query transformation time. So that's how Oracle relates to the other columns. That's why sometimes it's difficult to get Oracle to use an index if you've got this data type mismatch. It can see row counts associated with the subqueries based on statistics, and it likes to rewrite subqueries into inline views. It likes to take views and make inline views out of them, and I'm going to talk a little bit more about that. It also does what I call transitive behavior, and you'll see this. You see these things in the explain plan because explain plans have exposed the where clause items out of your query for quite a while. And any of you that have been doing any number of tuning for any length of time will notice there are subtle differences, sometimes major differences, in the where clause items as they appear in the explain plan as to what appears in your query. That is because of query transformation. One of the things that Oracle does too is transitive queries. It likes to add additional access paths if it can. It's looking for the optimal path, but it also likes to add additional ones. For example, if A equals B and B equals C, and you have these where clauses in your where clause, Oracle can say, well, then A equals C, and it will actually add that code to your query. Okay, and I've seen this, and I'm sure several of you have seen behavior like this. The no query transformation hint slows this behavior down. It will always do the data type mismatch type of rewrites. It'll always fix those things, okay? No query transformation will prevent the subqueries from being converted into views to be converted and does different things with them, okay? So query transformation likes to convert views to joins. And they've got different terminology here, and they've got hints that control all this stuff. And we'll probably have a lunch and learn just on hints, I would say. Subquery unnesting converts subqueries to inline views, or leaves them alone, and you'll see the view syntax appear in your query, your explain plan. If you see the view syntax appear, then it left it as a subquery. Otherwise, it changed it to an inline view. Now, what Oracle does is it will look at the subqueries, and if there's low row count, if it thinks low row count is going to come back from the subquery, it generally leaves it as a subquery. If Oracle thinks there's going to be a lot of rows processed in the subquery, it likes to change those to joins. It likes to change them to inline views. And that should be a direct hint to you on coding style. If you think something's going to come back with a lot of queries, go ahead and code it up differently, because Oracle's probably going to convert it anyway. Predicate pushdown, this is an interesting one. Predicate pushdown moves the where clause predicates into the subquery. Oracle, again, thinks that it will reduce the row count coming out of the subquery, maybe leave it as a subquery. There's hints that control all of this stuff, but query transformation is alive and well, and Oracle is doing a lot more with it. Now they're doing Oracle 11, they're converting group bys. Not in and not exists are also being converted to inline views. Okay, 10 and before, if the join predicate was null, wouldn't do anything with it. Now they're changing those as well. I have not heard yet what the Oracle 12 is doing, but I would imagine they've added some more query transformations even in Oracle 12. So you can turn this off. Generally, it's a good thing. With very few exceptions, I've not had to alter what Oracle thought was a good idea, generally was a good idea. What I want you to get out of this is learn from the way Oracle is rewriting your queries. Code your queries that way. Okay? So this is kind of how it all works. You submit a SQL statement. Oracle is going to check its syntax, make sure it's syntactically correct, and then it's going to look into the shared pool to see if it already has the SQL statement. If it already has the SQL statement, it's a soft parse, and it skips the permutations, it skips the row generation, goes right down to execution. Okay? This hard parse, this is really the hard parse steps, is the row optimization, which is the permutation process, and then generating an explain plan. Okay? And in there it is, query transformation occurs once, and then, like I say, it will do these permutations, roughly the number of tables times the number of where clause predicates that you have in your where clause. That's about how many permutations you're going to get, and then Oracle comes up with an execution plan. We're ready to rock and roll. This information came right out of the Oracle Performance Tuning Guide, and I've sat in on presentations where speakers from Oracle talked about these things as well, but I've known about this for quite a while. So today we did talk about what is involved with the hard parse, the permutation process, the query transformations, and how it all kind of fits together, and some tips on what to do with it, i.e. code the way Oracle is going to convert it anyway. Why? Because probably a better idea, probably more performant if you do that. The slides and the link to this presentation will be available shortly out on my website. Tell everybody about these Lunch and Learns. I'd like to get more of you involved. I think this is a really good idea, good use of my time, and I hope you find that it's a good use of yours. Thank you very much. Keep in touch, and do remember me for your training needs.